So I'm showing how to produce NMDS plots or non-metric multidimensional scaling plots in R using the vegan package. This is a way of using dimension reduction to visualize large multivariate data sets uh, in R. And what it does is it preserves dissimilarity between samples that you can see in just a two-dimensional plot. So first I'm reading in my data and then opening the vegan package. Um, so in the data set, I have 13 different entries, which are samples of biological communities across 3 different environments, which are just labeled A, B, and C. The first column is the labels for the environments, and then there's 190 variables describing the organisms in each community. And so in vegan, there is a function called meta NMDS where you put in your community matrix. I'm subtracting the first column so that we don't include the factors that describe the environment. You decide what distance measure you want to use, and I'm using Bray-Curtis, which is common for looking at differences between biological communities. And I'm going to transform the data as well. Meta NMDS will transform it for you, so I'm turning that part off. I'm using decostand to transform my data inside the actual meta NMDS function, where I am scaling it for each sample, the abundance of all organisms to be between 0 and 1, which is just common practice here. And then I'm going to put this in an object called data NMDS. Okay, so if we plot just the NMDS now, we can see black circles, which represent our samples, and then red crosses, which represent our actual variables and which direction they're increasing or decreasing in. And we can add things like ellipses to delineate groups of samples. So I'm going to add an ellipse that shows the centroid and the standard deviation of each group of samples. So what I'm doing is for this function, I'm putting in the actual NMDS file, or object, what I'm using to delineate different groups from our original data frame, and then which groups I want to show. And so when I do that, you can see a black ellipse around those groups of samples, which is labeled A. We can do it for a third group. We'll color it blue. There's that, and then we can do the same again for our third group. And then color it red. Oh, blue and red. So we can see 2 groups of samples are very similar to each other while they're very different from another one.